Can I record myself? Yes? No? Maybe?
Can you hear me now? What a crappy mics. Oh, I know something. Wait a minute.
I think this improvised microphone will suffice for now. The truth is, I've never done a video like this. I will do what I can with the stuff that I have, like mobile phone. That's basically it. But I do have a workplace that I've been really busy to build in the past year, and it's finally done. I'm trying to start for myself in 3D printing and prototyping, and occasionally making art. Now, I've been following Martin already for a few years, and I really like the stuff that he's making. I only never expected to be building a part for his new MMX machine myself. The parts that I'm making are the Cybercaps, or the Cyberbase wheels. These are the wheels that are running over the strings of the Cyberbase guitar. Martin made the sketch of what he wanted, and Richard turned it into a real drawing that you can build, and figured out what sizes everything needed to be. And Richard asked me to do the building part. I think Richard also came up with the idea to use Lego wheels for the rubber, which was a really good idea. Here I'm making the nylon rims. They are made from nylon so that they don't use any lubrication to run really smoothly on the metal polished axle that we're gonna make. It has a little groove in the middle, just like the original Lego wheels, to fit the rubber Lego wheels that we're gonna use. The nylon that I'm using now is an extruded nylon rod. I was searching for cast nylon as it has a little bit better properties than extruded nylon. It's a little bit more moist resistant, has a bit more dimensional stability and better lubrication properties. But I couldn't find any rod of this diameter, only much bigger diameters, which also brings up the cost significantly. But I think this will be good enough for what we're using it for. Here I'm going to make the steel axle that's gonna sit in the middle of the nylon rim. I'm gonna polish this as smooth as possible so that the wear that it has is the least I can get, and it will keep on running pretty smooth. When using abrasives on a machine, it's always smart to put something underneath it to catch the abrasive debris falling off it, to prevent it from coming into your bearings or in your slideways. I'm measuring in the more coarse sandpapers to find out if I'm still above my goal diameter, and when I reached it I can start using finer sandpaper. In between all the sandpapers, it's also really good to clean it first so that you don't have any coarser grit sanding debris still on your work, which makes coarse marks on your work while you're already using finer sandpaper. I'm using the tailstock on the lathe to make the metric tooth thread through the center. I got it free running on the slide, so it pulls itself in and out. But I'm turning the head with my hand. Only when I'm done I can automatically run it out. Here I'm using another tool to find the end of my workpiece and get a zero on my electronic scale. I don't know if this is actually the best way to do it. If somebody else knows a better way, I really like to know. But for me, it works so far. Now I'm going to make the frame for the wheels. I'm going to make this out of aluminum because I know Martin is using the angle grinder a lot, and when you're gonna grind aluminum, it will clog up your grinder, so I kind of hope to protect all the future works that people do by clogging up his grinder when he's gonna use it on this. The round feature on the end of the frame was something I was thinking about how I was gonna make this. At first I wanted to do this by hand because I don't have a turntable. But then I got thinking about using the divider that you use to make gears, for example, on the mill. I made a mock-up frame with a center point punched into it, and using a center as a way to find out when the fought jaw is in the correct position. And then by locking two of the jaws, I could mount different frames in it every time with the center point on the same place. And then I could mill the same radius on all the different frames that I put into it. For aluminum, I'm using WD-40 as cutting fluid. I'm applying this with a brush because I do love the smell of WD-40. I find it a bit too much to spray it around through my whole workshop. With a brush you use way less, you can do longer with it and it doesn't get everywhere. I'm taking really small cuts on this workpiece because I don't have the machines that long yet and I'm trying to learn how they feel. On the first test cuts that I made, I noticed there was a lot of play on the axles of this machine. So during this project I actually took apart the whole machine to get rid of all the play in all the slideways and bearings. And it seemed happy with all the new grease and oil that I put in it, as it happily sprayed around the axis around my workshop for the first few runs. Now the wheels are done following the design, but I came upon this problem where if you want to disassemble them, the axle can rotate with the last screw that you're trying to get out, and that way you can never disassemble it when the wheel is around it because you have nowhere to grab the axle. So I came up with an idea that should be helping with this, especially when Martin is gonna use Loctite on those screws, which is a really good thing because this will be vibrating a lot. I made a small slot on the arms and in the axle, so you can stick in a flathead screwdriver and hold the axle down while you're screwing out the last screw on the other side. From all the different options that we discussed with different people, this seemed to be the one with the least amount of modifications, and also the one that was done without needing to make new parts, and it was one where you don't see the modifications and the end results, because the slot was getting covered by the screw itself. Then there was also something else that I thought that could be better. When you have flat rubber wheels running on a string, you need to align this wheel and keep it in line really accurately in order to keep it from going off your string. I tried this on a bass guitar that I borrowed from somebody, and indeed they were pretty hard to keep on the string. So I decided to try and make a whole set of wheels with all kind of different grooves on it. I first wanted to go for bigger size grooves, but testing on the guitar showed me that the smaller strings would still walk easier out of the bigger grooves than making wheels specially have smaller grooves for the smaller strings. With the proper sized grooves in the wheels, the string is actually dragged with the wheel on its alignment error instead of the string rolling off the wheel. But I can also see a problem with this potentially, where the alignment error directs the string sideways, increasing its tension and thus also increasing the tone pitch. I will just make a bunch of wheels and let Martin figure out what works best. While making the grooves on the wheels with heat forming turned out really well, I still had a challenge on how to make them look nice, and I ended up using an ice bath and then using a Dremel in the lathe on the highest speed to get rid of the material before it warmed up and turned into a goo that would stick to everything. I hope these wheels find their way safely to you, Martin, and I wish you good luck with finishing your MMX machine, and I hope to see it somewhere in real life sometime. Now, if you haven't seen the marble machine yet from Martin, or the new marble machine that he's building right now with the community, you should definitely take a look at his YouTube channel, Wintergatan. I will put a link to it in the description below or somewhere here on the screen. It's a real marble machine. I mean, marvel of a machine. Actually, it's both.